So today I am going to be talking about how citizen scientists found Steve. So, first of all, who is Steve? Steve is not some person standing out in a big city, no. Steve isn't a who, Steve is a what. And what Steve is an aurora. But not that aurora, that's the aurora borealis. That is Steve. Steve is a previously unknown aurora to science. So, first let me just describe what an aurora is. An aurora is caused by charged particles from the sun coming out towards the earth, carried by the solar wind. They're deflected by the Earth's magnetic field, but some of them make their way to the poles. And that is how we get the remarkable lights we see when the charged particles interact with our atmosphere. So aurora are typically found in two areas. The northern hemisphere has the aurora borealis, and the southern hemisphere has the aurora australis. And so this is roughly where you see the aurora borealis, but Steve is different. That's where you find Steve. It's much further south than the aurora borealis, and it covers a huge area, as you can see. It's like someone's taken a purple marker and just drawn across the sky. And it moves really quickly as well. These particles are moving very fast across the horizon. So there are two scientists who worked on this paper, Dr. Elizabeth McDonald and Eric Donovan. So what happened was, Dr. Elizabeth McDonald was giving a presentation at the University of Calgary in 2006. Eric Donovan is a professor at the University of Calgary. Elizabeth McDonald is a NASA scientist. At this presentation, there was a huge number of people, way more. Just for some reference as well, the University of Calgary is up here in Canada, just in the Alberta area of Canada. So what was happening was, there was this huge Facebook group, the Alberta Aurora Chasers, and they were making their way to these talks and filling up the entire lecture theatres. They've got about 17,000 members at the moment. And after this presentation, they do what most scientists and the public do. They go have beers. And at this bar, they were chatting and sharing pictures of some of the auroras they take. It turns out some of these aurora chasers are actually some of the best aurora photographers in America, in the northern states. And then one of them said, "Oh, I happened to catch the photon trail last night, the photon stream." And Eric said, "No, hang on. No, you can't have seen the photon trail. It's subvisual. You can't see it." And he said, "Well, I took a photo of it. See, there it is. Took a photo." And the two scientists went, "Well, hang on. That's not a photon trail, photon stream. That's not even the aurora borealis. That's something else. That's something they didn't know about." And they sat there and they talked about it all night and decided, we're not going to call it a photon stream anymore. We'll call it something else. Just, you have to name something else. A couple days later, they were on Facebook and then someone said, "Why don't I call it Steve?" Referencing Over the Hedge. So in Over the Hedge, the animals wake up from hibernation and they're confronted with this huge hedge that never existed before. And they're scared and they're confused and they think, well, hang on, why don't we give it a name? So we'll call it Steve, so that way it's not scary. Now this aurora is not scary, but the name stuck. And over the coming months, people took photos of Steve. They say, "Oh, I spotted Steve over the lake last night. Oh, I spotted Steve yesterday." And what happened was, these scientists were trying to find Steve in the data. They have thousands of cameras all over Canada taking photos of aurora and getting data back in real time. And they're trying to find what Steve was. And one night, they think they found Steve. And they asked the Facebook group. This is the first time this scientist ever thought to ask the public, "Hey, Did anybody see Steve last night? Yes. And they were able to match their data with the picture of Steve and go, these are the same thing. And it just so happened that the European Space Agency was flying a satellite, and it flew right through Steve, the European swarm satellites. And these come with all kinds of great scientific instruments for studying aurora and magnetic fields and all those kinds of things. And they were able to get this great data set of Steve. So what exactly is Steve? Well, it's 25 kilometers wide. It has an altitude of 450 kilometers, a temperature of 3,000 degrees Celsius, so it's actually basically the hottest place on Earth at the time, and it flows at 6 kilometers a second, which is much faster than the surrounding area. The surrounding environment in space would be 10 meters a second. That's 6 kilometers a second, hugely different. So this is a completely new phenomenon. This is something never before seen. And with the help of the public, they were able to find and study this. And then, of course, they were trying to work out what Steve could stand for. So there's a thing called a backronym, where you start with a word and you work back to find the words that match. And as Eric was presenting this paper, one of his colleagues suggested, why don't we call it the Strong Thermal Emission Velocity Enhancement, which describes what it is. And so with the help of citizen scientists and NASA and the European Space Agency, they were able to accurately describe what Steve is as a new phenomenon. Thank you.